Welcome to the Introduction to Isolation Part 2. Hopefully you've had time to review Part 1 of our video where we covered some basic theories and concepts of isolation. Now it's on to some more topics. Again, the agenda between these two videos will include technical reviews of general theory and knowledge. Now we will get into some key terms and specs and finish out with some markets and applications. Before, we ended Part 1 by showing you a cross-sectional view and a bird's-eye model of our internal isolators. Now, let's look at some actual pictures of real isolators. Here is a capacitive-based isolator which gets its isolation at the process level. You can again see our two-die setup that is then bond-wired together. Optical-based isolation, which gets its isolation from the package level, is acquired here. You can see a cross-sectional view of the transmit and receive chip setup, which would then be covered with mold compound. And lastly, we have our inductive-based isolators, which have integrated at the process level its isolation technology through the inductive coils. Let's get into some terminology. First, we have the isolation rating, also typically given in VRMS and listed as the spec VISO. This is the isolation level defined per 1-minute testing, usually through certification boards such as UL, garnered through specification 1577. Next, transient overvoltage rating, typically given in VPeak, also associated with spec VIO-TM. This is a peak voltage that may occur temporarily across the barrier. Third, we have the working or operating or repetitive voltage, again typically given in VRMS. It is also associated with spec VIO-RM. This is the voltage that may be applied continuously across the isolation barrier without degradation over the lifetime of the product. Another important spec is the impulse or surge voltage, given in VPeak. This is associated with VIO-SM. This is the highest level voltage that can be applied over a very short but specific amount of time and still retain the isolation integrity. It's typically associated with electrofast transients or quick spikes in energy and the ability to handle those. Next, we have basic or functional isolation. This is an isolation level associated with the isolation rating voltage. It's a classification of the isolation that your isolator is capable of having or withstanding. It usually assumes a single level of isolation. Using two basic or functional devices in series can create what is called a double isolation rating, and this value can be used in the calculation of that value. After basic or functional, you can then get into reinforced levels of isolation. Again, this is an isolation rating correlating to the isolation rating VISO, but assumes a single level of isolation that is as strong as two basic or functional isolations in series. The next spec we would like to talk about is common mode transient immunity, or CMTI. CMTI is the change in ground 1 relative to ground 2, and it's measured in kilovolts per microsecond. If you think about it, it's the rate of change one signal can go through without triggering a false or a corruption on the output. The next spec is creepage and clearance. These are usually garnered from a mechanical engineering point of view, but are very important when designing any system. Creepage is the distance along the surface of the package from input to output. Here it's shown as the distance along the top, but it could also be along the side or the bottom. Clearance, on the other hand, is the distance from input to output pin through air. In the description above, it's shown as a line of sight, but in reality, this value could be a bent line, making it shorter. Here are some typical values for creepage and clearance of the packages some of the packages we use at Texas Instruments. Lastly, we can show you some discovery questions. These are questions to think of when designing any isolation system. What level of isolation is necessary? Is it basic and functional, or is it reinforced? What are the certifications that you're designing to? What level of isolation do you need for VISO or for working voltage VIORM? Do you need just a standalone digital isolator, or would you need an isolated function device, such as an isolated RS-485, isolated CAN, isolated gate driver, or even an isolated data converter? What are the supply voltages that you're using? If you are using just a digital isolator, how many total channels of isolation do you need, and in what direction do they need to be going? And lastly, what is the Transient Immunity requirement, or the CMTI? Now we will look at some brief markets and applications of isolation. First, isolation has a very strong place with the industrial market. It can be used in robotics, PLC for input and output isolation, industrial networks, motor control, or power supplies. The primary task? You guessed it, isolating between high power and control signals, or isolating specific nodes to prevent corruption. Digital isolation also can be used in other markets, such as medical or communications equipment. In both areas, it's used to isolate between power and delicate circuitry in the system. With communication equipment, it can also be used to isolate individual bus nodes to prevent corruption of the entire bus. Lastly, digital isolation can also be used in consumer and computing or office equipment and other white goods. Again, the primary task is to isolate between high power and delicate pieces of the system. This concludes our two-part series as an introduction to isolation. We hope you've enjoyed it, and if you'd like to learn more, please visit www.ti.com/ISO. Thank you very much.